Education in primary schools is always changing. As identified by Boyle, many different changes have occurred over the years, and different approaches are always being suggested to be the best method for teaching in primary schools. One method that has been suggested to be used in schools is cross-curricular teaching, which will be discussed throughout this presentation, looking at the advantages and disadvantages, specifically looking at the links between maths and science. Firstly, it is important to understand what cross-curricular teaching is. According to Hayes, it is the combination of one or more subject areas which integrate a central theme, issue, process, topic or experience with the aim of enhancing more than just subject knowledge. Over the last few decades, cross-curricular teaching has been widely debated as to whether it is the best method to use in schools, or whether the more rigid method of discrete learning, which focuses on one subject, should be used. This debate will be discussed throughout the presentation. Cross-curricular teaching is a concept that has been discussed for over 100 years. Dewey believed that by searching for examples of robust links between subjects that take account of discrete learning and relate them through children's experiences. The Hadel Report in 1931 endorsed the move to a cross-curricular teaching and the benefits of using it in schools. Piaget's constructivist theory is considered very influential in the field of education. His work suggests children form meaning from their own experiences, and teachers are facilitators whose role is to aid the pupils into their own learning, providing motivation for cross-curricular projects. In the Playden Report in 1967, it was suggested that some work should cut across other subjects at all stages of the primary school, but also looked at how discrete learning has its place in the classroom. In 1988, the national curriculum used more of a rigid approach and did not push a cross-curricular way. The Three Wise Men report by Alexander, Rose and Woodhead in 1992 was very much for discrete learning, as they believed that lessons should be taught through a single subject approach. However, an Ofsted report in 2002 was the biggest move to a cross-curricular method, as it is described as a strong feature of successful schools. Also, in 2009, the Rose Review showed support for cross-curricular teaching, stating high standards are best secured when subject knowledge is applied and used in cross-curricular studies. With the influence of Rose's report in 2009, the National Curriculum Reform in 2014 implied that learning needs to be delivered in a thematic style, where a theme is used across different subjects as suggested by Hayes. There are many advantages and disadvantages to teaching in a cross-curricular way. There is no doubt that children are the most important to consider when it comes to teaching, so it is essential to look at how cross-curricular teaching affects them. Firstly, Price found that by intertwining subjects, children become more aware of the thinking skills they are using and will be able to apply their knowledge more easily, thus improving confidence. It is important that children are able to think in different ways and apply the knowledge they gain into different areas in their life, and teaching in a cross-curricular way can help this. Barnes described the world as being cross-curricular because everything in the world can be seen and understood from different perspectives, whether they may be in a geography lesson and understanding the mathematical skills that are required to read scales in maps. Claxton states that learning in a cross-curricular way provides less fragmented but more stimulated learning experiences, allowing children to apply new knowledge in a different context. There are also many benefits to the teacher and school by integrating subjects. One of the clear advantages is the fact that it will save a lot of time. If, for example, you are doing an investigation in a science lesson which involves graph work, you'll be saving a lot of time in your maths lessons, as it will not require as much teaching input. This will reduce the teaching time and may even provide time to broaden the children's understandings. This lesson may also be used as a base for assessment. Even though it is a science lesson, there is no reason why the investigation can be used as evidence for assessing the children's understanding in maths of line graphs. It is also important to consider the disadvantages of teaching in a cross-curricular way. One of the disadvantages of cross-curricular teaching is the professional development and time needed to be able to teach in a cross-curricular way that is effective. Time is very important in the school, and a teacher would struggle to find time to ensure they have a full understanding of teaching in a cross-curricular way. Cross-curricular teaching can all be seen as taking the importance of topic work away and losing its meaning. For example, if in a science lesson which is based around reading scales, it could be possible to move away from the actual investigation and focus too much on reading and interpreting the scales. This will in turn remove the focus away from the science and therefore losing the subject's identity and characteristics. Westwood looks at the difficulties teachers face and how it is difficult to broaden the children's minds and at the same time avoid confusing them. Discrete teaching clearly has its benefits, and as Penny explains, children who are not comfortable with change will not respond very well to cross-curricular learning, and in effect can cause behaviour and classroom management problems. Rosen is for teaching discretely, as it provides the best platform for young children to gain a full understanding of the lesson without any distractions. Maths and science are two subjects that are very strongly interconnected. Without mathematical subject knowledge, it would be difficult to gain a full understanding of scientific inquiry. In return, science provides a context to apply what we learn in maths. Some of the many links include solving problems, graph interpretation, reading scales, measurements, and recording results. Kelly looks at how cross-curricular learning in science enables independence in the learner, as they will be able to see the relevance of scientific skills. To ensure that pupils can apply their knowledge, it is important to teach them in a cross-curricular way and ensure the pupils understand that not only are they gaining scientific skills, they are also applying their mathematical knowledge. In the new national curriculum in 2014, it is clear that it is important to apply your subject knowledge to different areas. Within the science national curriculum in Year 5, children are expected to look at properties in their materials. One experiment which would then work in a cross-curricular way is observing the changes in water with evaporation. In the lesson, the children will be taught to work scientifically and discuss the concept of evaporation using scientific vocabulary. In the lesson, beakers with the same amount of water will be placed in different areas around the school, with different temperatures. The mathematical side of the lesson will involve reading the scales to see how much has evaporated, as well as recording the results of the investigation into a line graph, which is also part of the Year 5 national curriculum. The results would then be interpreted to see the best place for evaporation to occur. The mathematical side of the lesson could even be used in a separate learning objective, where the child needs to achieve. The pupils would then understand that they could achieve the lesson objective for science, but also another learning objective for maths. This table is used in a school, and the children fully understand that they are working in a cross-curricular way without removing the scientific inquiry. Another way of teaching in a cross-curricular way is by linking the lessons by a theme. For example, one of the themes that could be used which appears in the Science National Curriculum is Earth and Space. While the topic is being taught in science lessons, in maths the children could produce a bar chart showing the number of days that each planet has in a year, as well as a line graph showing the number of hours in a day on different planets. This way, not only are they learning about constructing and interpreting bar and line graphs, they are also reinforcing their knowledge of Earth and space. This could apply to other lessons across the timetable, such as literacy, where they could write a recount of an astronaut's trip to space, or in art, where they could make scale models of the different planets. The thematic approach is supported by Hayes, as well as the new national curriculum. ICT is a very useful tool which can aid in cross-curricular learning. ICT provides a very simple way of producing graphs, tables and charts. In a science lesson which involves gathering a tally, looking at sustainability and how pupils travel to school, the information could be changed into a pie chart using ICT, and giving the children a visual representation that can be quickly made without losing any of the mathematical or scientific skills. This limits the time spent on the lower level skills of gathering, recording and presenting data, and allows more time for the higher level skills of interpreting and drawing conclusions. ICT can be very effective to create independence in a lesson. It can be very useful to give pupils the chance to research a topic instead of just giving them the answers. For example, in a science lesson based around classification, the children could be given time on iPads to research the topic and even create a poster based around food webs that they have independently researched. The use of ICT in programs such as Education City can also be valuable for revision. However, as Howland suggests, it is important that the learning is not just for learning's sake, and the pupil's work needs to have meaning, and this is in line with Piaget's theory. Therefore, when using ICT, it is important to make sure that it has meaning. According to Gillespie, new technologies can be used in science to enable students to collect science information, interact with resources such as images and videos, and to encourage communication and collaboration, as well as improving motivation in science. Cross-curricular teaching has its advantages and disadvantages, and it is clear that both discrete and cross-curricular have their places in the classroom. It is also very clear to see that maths and science have very strong links and can provide platforms for excellent work. ICT is also clearly a very useful tool and can be used in both maths and science lessons to make them more engaging for the children if it used appropriately you.